According to the law of conservation of mass, matter cannot be created or destroyed, merely rearranged. So then why is it so common to get less product from a reaction than you would expect when you do the calculation? Basically, we're human, we're fallible. We make mistakes. Maybe we spilled a little chemical when transferring to a different container. Maybe we heated the substance for too long or not enough time. The number of possible errors are plentiful. So to figure out how much substance we actually made compared to theoretical perfection, we use percent yield. To calculate percent yield, you take the actual yield from the experiment you performed and divide by the theoretical yield that you calculate, then multiply by 100 to get a percentage. Let's try an example. Often percent yield calculations are done with stoichiometry problems, and that's the case with this example. What is the percent yield when 5.5 grams of magnesium oxide are recovered after burning 4.9 grams of magnesium in sufficient oxygen? First, let's identify which bit of data is the actual yield. 5.5 grams of magnesium oxide are recovered. That means the lab was actually performed, so this number is the actual yield. The second number is our starting point for the stoichiometry problem we'll solve. The reaction is magnesium with oxygen to make magnesium oxide. You always want to write a balanced equation to get the correct number of mole ratios. Now we'll start with a given amount of 4.9 grams of magnesium. We'll use the molar mass of magnesium from the periodic table, then the mole ratio of magnesium to magnesium oxide. We get those numbers from the balanced equation. Then the molar mass of magnesium oxide, again, using the periodic table to add it up. The answer to this calculation is our theoretical yield. Now we can find the percent yield by taking the actual yield and divide it by the theoretical yield. We'll multiply that by 100, and we get 67.7%. That's a pretty low percentage for a yield, so we're probably making a few errors in the process. Hopefully you get a better number than that. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.